Okay, so I'm looking at my DIY CPU project again, and this time I'm looking at combining two of my registers. So I've made two registers so far. This was the one at the bottom here is my register that I made on on breadboard, and it's quite elegant. I quite like that register. I think that's the design that I'll go with from now on. And the register slightly higher up is my first attempt at a register on stripboard, which is a bit of a bulky old thing, and I didn't do quite such a good job on that one, I don't think. I didn't choose the ICs quite so well, but it still does the job. So what we've got here then are two 8-bit data storage registers, each capable of storing an 8-bit binary number. And I've got them linked together with this little connector here, and so they're all on the same data bus with my Arduino, which is linked by these pink wires up here, which is so basically all three, the Arduino and the two registers, are on the data bus. Now I'm just using an Arduino because I don't have anything else in my CPU apart from two registers, which makes for a bit of a boring CPU. So I have arranged it so that I've got an Arduino doing all the work, sort of emulating the rest of the CPU, and the registers sitting here just responding to whatever the Arduino tells them to do. So what it's actually doing at the moment, I've written a little program in the Arduino, and I am publishing an 8-bit number picked at random by the Arduino onto the data bus at the top here. The data comes onto the data bus, and the data flows all the way down this data bus on the that I've sort of made on this register. These 8 strips of copper on the strip board are actually my data bus, coming down here through this connector and into this CPU, into this register here, and the data is therefore able to flow through the anywhere through the data bus and into either of these two registers, and also into the Arduino. They're all connected together. I'll show you a diagram actually of how they're connected up. It's a little bit clearer. So we have registers. Let's call them register A. Well, that can be the top one. Register B, that can be the bottom one. And the Arduino, I suppose I've got my diagram upside down to how it is in real life, and they're all connected together by these 8 wires which form the data bus. So if this right hand wire here coming out of the Arduino is taken high, then this line here for register B will also be taken high, and this line here for register A will be taken high. So that means my Arduino can put a value onto the data bus, publish it, and publish it onto the data bus, and the registers can read it and store it. So what I'm doing in my program, you can see that the top register gets given a random value, and the random value then appears in the bottom register. So it goes those 2 bits, those 3 bits, those 3, that lot of bits, that lot of bits. And this is how it's working. The Arduino is coming up with a random number. So let's say that number was 10101010, and it's publishing that number onto the data bus. And remember, the rule of data buses is only one person can be publishing, or only one thing can be publishing onto the data bus at any time. So the Arduino publishes those numbers. And so if the Arduino publishes those numbers, they're available everywhere on the data bus to everyone who's listening. So anyone can listen to that number that we've published on the data bus. And then I'm telling the register A to store the data. And that is done through these control lines to my register. So I've got on this register, I've actually got too many control lines. I only need 2, the store and the publish control lines. And on the lower register, I've got a store and publish that one will be store, that one will be publish. One is to store a value in the register, and one is to publish that value back to the databus. So if you are publishing from the Arduino and you're storing into register A, you're going to get the value of 10101010 stored in the register A. And at that point you can stop publishing, so the databus now doesn't have that value on it, and the value stays in the register. And what I'm doing next is, in my sort of not very interesting CPU example, is I am telling register A to publish. So if register A publishes its value, that value will be available everywhere on the databus. And I'm then telling register B to store. And so because A is publishing that number and B is storing that number, the number ends up in register B, and I can then tell register A to stop publishing, and so register A keeps its value and register B has now got that value. So that's what I'm doing with the registers, just a little program in the Arduino that controls these data lines onto the data bus and the data pins. And you can see it in action. So the Arduino is putting a value onto the data bus. The data bus is being stored in register A. I've got a time delay of about a second between each action. The value appears in register A when it's stored there. It's then published back onto the data bus, comes down here, it's stored in register B, and what I'm then doing is publishing it back off of register B, back through the data bus, back to the Arduino, reading it back into the Arduino and checking that the value that flowed through this circuit and came back to the Arduino is the same value that I started out with. I'll just change the code now to take out the delay, and I'll see how quickly I can write and do this without losing any data. Okay, so let me just run that, and there it goes. So it's going really, really quick, so it just looks like they're permanently on, and now it's stopped. And according to that, I've run that twice now, and we've done 10,000 tests in 3 seconds. So we've done 3,300 tests per second. Is that right? Yeah, 3,300 tests per second are there. All the tests are passed. So I've stored a number into this register, passed it through to the other register, and read it back to the Arduino, and it can do that at 3 kilohertz. And that upper limit is limited by the speed of the Arduino program, not by the register. It's just my crummy Arduino programming skills, I think.